Hi, my name is Claire, and this is my Comp3095 in-class exercise 2 demo. Containerized microservices with API, gateway, and caching. Student ID 100882058, course name, web application development using Java, course code Com3095, course section 18344. I built a microservices system with product service, order service, inventory service, Redis, MongoDB, PostgreSQL, and an API gateway using Spring Cloud Gateway, all containerized with Docker Compose. Here's my GitLab repo under microservices parent. You can see all directories, you go, and members. And 2 professors are invited as a reporter. I just showed my name and student ID, course code, lab title, technology used, GitLab private repo. Professors added with reporter access, Docker Compose, and all services present. Following this checklist, I'll now begin my demo. For Docker Compose, here you go. We have order service, port 8082. Product service uses port 8084. Inventory service uses port 8083. And API gateway uses 9000. Route, you can see product service, order service, inventory services. All the containers are up and running. We'll run Docker, yes. API gateway 9000. Here you can see all required containers are running. Here on the checklist, the required containerized environment includes API gateway, inventory service, Mongo, order service, pgadmin, Postgres inventory, Postgres order, product service, Redis Insight, and Mongo Express. And Docker PS and port mappings are done. And now we'll go test out all API. In Postman, here I call API/product. And we got 200 OK, fine. And we'll test orders as well. 200 OK again. And inventory, 9000. 200 OK. All these go through the gateway, and I never call the microservices directly on 8082, 8083, or 8084. 9000, 9000, 9000. Here we'll do okay, cluster. And we'll do blue. And we'll do 799. Post. Now I created a new product using post 9000/API/product. Through the API gateway, the product services is behind the gateway, but I only talk to 9000. And we'll update with this. 204. Here we can see it's updated. The data has been updated. Now we'll check. Delete. It's working. 204. We'll check. Took some time to disappear, but here the data has been deleted successfully. This shows that all product CRUD operations go through the API gateway only. Now we'll go to inventory and then see it in stock. Nokia Classic. 50. In stock shows true. And we'll create one more out of stock this time. It's been updated. And I created 2 inventory records just now, see it in stock. That was Nokia Classic, quantity 50. And the other was Sony. And these are out of stock. In stock false. I'll use these SKUs to show a successful order and a failed order. Here we're calling inventory service to check the stock status. Here they're calling inventory service and convert array to map. All the logics are here. This is how the order service talks to the inventory service. It collects the SKU codes from the order and calls API/inventory using web client inside the Docker network. The inventory service returns in stock booleans if any SKU code is missing in inventory or out of stock. Missing SKUs, throw this message. And the order is rejected with 400 error. Only when all SKUs are in stock, the order service save the order to PostgreSQL. Save the order to PostgreSQL. To successfully place order. Successfully placed order. And we had, and it throws 400 batch requests. And we'll check Docker logs API gateway. My orders. Now I place an order, which is in stock. Use this. Here. All requests route correctly. We just check this. And inventory was called. Get request API/product twice. Next, I'm demonstrating Redis caching inside the product service. I'll make 2 GET requests to API/product, 69 milliseconds, and second time it hits the Redis caching, which was faster, 22 milliseconds. So on the first call, the product service hits MongoDB. This is a cache miss. Submit. Post Redis password. I'm using Redis Insight to inspect the Redis server inside my Docker environment. Inside Redis Insight, you can see after the second call, MongoDB is no longer hit. Instead, the result comes from Redis. Here in Redis Insight, under DB0, you can see the cached key created by Spring Cache. Cached JSON response from the product service is stored. This confirms that Redis caching is working behind the API gateway. So we've done this. Finally, I use JUnit and test containers to run integration tests. These tests spin up real Redis and PostgreSQL containers for the product, order, and inventory services. All tests pass, which verifies the caching behavior, the order, inventory integration, and the inventory to database integration. I'll pull out the checklist, and these are done. All tests pass. Show how test containers spinning up real DB. Our integration tests use test containers when the tests run. Spring Boot automatically starts a real PostgreSQL database inside Docker. PostgreSQL, and right here, connection, PostgreSQL, connection. We're not using H2 or mocks. It's an actual running DB instance. Test containers handle the lifecycle, spins it up before the test, and destroys it afterward. We've completed all the checklists. To summarize, I implemented 3 microservices behind an API gateway, Redis caching, PostgreSQL, and MongoDB, and inter-service communication, where order service calls inventory service and decides success or failure based on inventory. I verified the behavior using Postman logs, Redis Insight, pgadmin, and test containers-based integration test. All product CRUD and all order and inventory calls go strictly through the API gateway. The intercommunication was confusing at first, and there were some difficulty connecting it together. But in the end, I've successfully implemented everything. This is the end of demo. Thank you for watching.